All right, so this is our 10.2 Ed puzzle for Molly Mathematics. So in 10.2, we're going to talk all about triangles, okay? So let's jump right in. Of course, you know a triangle is a three-sided figure. So we have several different kinds. Oh, that looks bad. Let me start that over. Ooh, wow, okay. So anything that has three sides is deemed a triangle. Um, and we can make a triangle using two parallelograms. So if we take two parallelograms and then we just connect them together, that part in the middle makes a triangle. That way, if that's the case, then we know we have, here's angle 1, 2, 3, 4, 5. Okay, so then just what we had learned previously about angles, we can make some assumptions then about triangles. That angle 1 and 2, so angle 1 and 2 have to be equal. Whoa, let's try that again. There we go. Angle 1 and 2 are equal to each other. So then angles 3 and 4 are also equal to each other. Okay. And then angles 2. So angle 2 plus angle 5 plus angle 4 should all add up to be 180 degrees. And that's kind of how we know that something is a triangle, is because all three of the angles add up to 180 degrees. So if you look here, 2, 5, and 4 add up to 180 degrees. And then 1, 5, and 3, so let's write that down as well. Angle 1 plus angle 5 plus angle, well, that plus sign is bad, plus angle 3 all add up to 180 degrees. Okay, so all of the interior angles on the inside of the triangle have to add up to 180 degrees. That's how we know that something is a triangle. So let's look at a couple of examples. Let's erase. Nope, that's not going to work. All right. So here is a triangle that is listed in your book. It's kind of hard to draw these. So this angle right here is 17 degrees. That angle in that corner, we don't know. And this angle is 120 degrees. Yeah, it's supposed to be a 2. There we go. It's a little better. So if I want to find out that third angle, what I'm going to do is I'm just going to remember that all three of the interior angles have to add up to 180. So if that is A, and this is B, and this is C, then I know that A plus 120 plus 17 has to equal 180. And my pen skills today are horrible, so we're going to transition to a text box. So then I'm just going to solve for A. So A plus, and then I'm going to add 120 and 17, which is 137, equals 180. So then I'm just going to subtract 137 from both, 137 from both sides. So 180 minus 137, and that is going to equal 43. Okay, there we go. All right, so that's our first example. Example 2 in the textbook. we have this very strange looking thing. So we have a straight line here. We have a straight line coming down here. We're going up and then back down here. Okay, so this is angle 1. This is 2. This is 3, 4, and 5. And then this is 60. And this is 43. Okay. Let's do that. Okay. And then we're asked to find angles 1, 2, 3, 4, and 5. Okay, with what we know. All right, so I know if this is 43, this angle right here is a 90-degree angle. I can tell that just by looking because those lines are perpendicular. So I know that 1 is 90. All right, so for that first one, whoops, come on, there we go. So 1 is 90 plus the 43 that's there, plus x for number 2, angle number 2, and all three of those add up together to give 180. Well, 90 plus 43 gives me 133. Okay, and then I'm just going to subtract 133 from both sides to get my angle number 2, and that turns out to be 47. So angle number 1 is 90, and I tell that just by looking and seeing that those are perpendicular lines, which make them 90-degree angles. Okay, so then I've got to find 3, 4, and 5. Okay, all right, so if I look at that, I can look at number 4 and use the fact, okay, wait a minute, stop. This is 20, oh, I'm sorry, that's not 27. That should be 47, there we go. So if number 2 is 47, then number 3 is also 47, since those are vertical angles. So let's start making our list. So angle 1 is 90. Angle 2 is 47. Angle 3 is 47. Again, I know that because those are vertical angles being directly across from each other. So if I know angle 3 is 47 and I know this angle up here is 60, I can say that 47 plus 60 plus y, which would be angle number 4, how all those three have to add up to 180 degrees. So 47 and 60 is 107. And then I'm going to solve for y just by subtracting 107 minus from 180, which that equals 73. Okay. So angle 4 equals 73. So I have to find one more angle. I can't spell angle. Angle 5. So angle 5, we're going to find by the fact that these two are side by side. If these two are side by side, they have to add up to 180, which means they're supplementary. So I'm going to say that angle Z, we'll say that's for 5, using a different variable every time, is going to equal whatever 4 is, which is, hang on. So angle 4 is 73 plus Z, which is angle 5. Those two things are going to add up to be 180. Okay, so Z is going to equal 180 minus 73, which is 107. So angle number 5 is 107. Okay, I can make sure that that seems right because I can add all three of those angles back together. So I can add 43 and 90 and 47 and make sure that's 180. And then I can add 60 and 47 and 73 and make sure that that's 180. Okay. All right, so let's look at the different kinds of triangles we can have. We can have acute triangles. So these would be acute triangles. We can have right triangles, which has a right angle in it. That's how you know it's a right triangle. Acute triangle, everything, all the angles are acute. That means they're all less than 90. In a right triangle, you have one angle that is equal to 90, and then you can have obtuse, which means you have one angle that is greater than 90 degrees. Okay, so this is acute. This is right. And this is obtuse. Okay. All right, then we can also have isosceles triangles. It's going to be really hard to draw that. That's pretty good. And then we can have equilateral triangles, which I think that one's the one that's going to be hard to draw. Maybe not. And then we can have scalene triangles. And okay, so let's look at these. Isosceles means that two of the sides are the same. Equilateral means all three sides are the same. And scalene means none of the three sides are the same. Okay, so know those definitions and those terms, and that's going to help you. If you have, yeah. Okay. All right, so similar triangles is a big deal. So if you look at two triangles, figure 10, 18 in your book, let's see if I can draw it up here. So we have that and that and this. So that's 8 inches, that's 6 inches, that's 4 inches. Then I have another triangle. And this triangle is 3 inches, 2 inches, and 4 inches. Okay. And you see these weird little abbreviations. So the little angle thing with 2 slashes in it means that those two angles are the same angle. And this one with 1 means that those two angles are the same angle. And this one with 3 means that these two angles are the same angle. Okay, that's what all those little dots and lines mean. So figures that have the same shape but not necessarily the same size are similar triangles. So we can look at that and we say, okay, they look like they have the same shape. They're definitely not the same size. So are they or are they not similar triangles or similar figures is what we're going to look at. So if you look at the angles, so angle, okay, let's letter these. So that's A, B, and C, and this is D, E, and F. Whoa, there we go. So angle ABC and angle DEF are similar. So that's just, they're showing you that with this little funky sign here. That just means that they're similar. They're the same angle. Angles A and D measure the same number of degrees, and so they're called corresponding angles. So this angle and this angle are also the same. They're called corresponding angles. and this angle and this angle are the same thing, they are corresponding angles. So if the angles are the same measure, then those are corresponding angles. The sides opposite a corresponding angle are corresponding sides. Okay? So these are all things you got to kind of memorize. So corresponding angles are ones where they have the same measure in degrees. Corresponding sides are opposite of those corresponding angles. Okay? Corresponding angles in a similar triangle, corresponding angles have the same measure and the ratio of the lengths of their sides are the same. So let's write that out. That's the definition of a similar triangle. That's how you're going to know if this is a similar triangle or not. So the corresponding angles have the same measure and the ratios of the lengths of the corresponding sides are equal. Okay, so that's how we know that something is a similar triangle. So if we look at our example, we see all of those angles are the same. So we got that going for us. Let's look at the corresponding sides. Okay, so if we look, here's angle A, the corresponding side to angle A. And the way we write this is we look at the line. So here's A, the side opposite of A would be side CB, and that's equal to 8. If we make a ratio of CB over FE, which is the corresponding side on the other angle, same angle, the opposite side or the corresponding side is right there. That would be FE, and that is 4. So if I make a ratio of 8 to 4, that is 8 over 4, which is 2. And then I look at another side. Pick another one. So let's look at side CA. Let's look at side CA. That is 6. And then I look at side DF, and that is 3. Well, if I make a ratio of those two, 6 over 3 is, guess what? 2. And I look at the third side. So I look at line AB, and that line is 4. I look at line DE, bottom part of the other triangle, and that is 2. And then, of course, a ratio of 4 to 2 is 2. So those would be similar triangles because all of their three sides, the ratio of those three sides is equal to the same number, and all of their angles are the same angle. Okay. All right, so we can use that information then to try and find an angle or a side that we don't know. Okay, so here's this next example is using those similar triangles. All right, so let's draw the figure for example 3. Let's try to draw it anyway. So we got that, we got that, we got that, we got this. Okay, so there's one angle, and that's going to be equal to that angle. This is X. I don't know that side. I know that is 8, that is 5, and that is 7. Okay, so if I make a ratio of 5 over 8 and 7 over X, and I set those two ratios equal to each other because that's what similar triangles do. The ratios of two sides are equal to each other. So I'm going to say, all right, I'm going to say 5 over 8 is the same thing as 7 over X. And then I'm going to find x. The way I'm going to find x is I'm going to cross multiply and divide because I made a proportion. So that's 5x equals 56. So x is equal to 11.2. Okay. So this side over here is 11.2. All right. So some other problems, more word type problems involving similar triangles. So this would be example 4. A man who is 6 feet tall is standing 10 feet from the base of a lamppost. The man's shadow has a length of 4 feet. How tall is the lamppost? All right, so here's the lamppost, okay, and it's going to cast a shadow, and that is going to make a triangle. Well, there's one triangle. Now the man is right here. He also is going to cast a shadow and make a triangle. So his shadow is going to be 4 feet long. Okay, so 6 and 4. And then the whole base of that other triangle, the big triangle, is 10. And we need to figure out that side. So again, we're just going to make a ratio of the two vertical sides to the two horizontal sides. Okay, so we're going to make a ratio of, oh, actually, that's not all 10. Sorry, I drew that wrong. That whole thing should be 14 because this part is 10. Okay, so I'm going to make a ratio of the two vertical ones. So x, oof. Let's go back to using, no, never mind. So x over 6, because those are my two vertical lines, has to be equal to the small triangle, which is 4, over the bigger triangle, which is 14. So the length for the small triangle over the length for the entire bigger triangle is 14. Then I'm going to cross multiply and divide again. And that's going to give me x equals 21. So the lamppost is 21 feet high. Okay. All right. The next thing we're going to talk about is Pythagorean theorem, and you'll probably remember this, but Pythagorean theorem basically just says that when you have a right triangle, this only works for a right triangle, that we have A, B, C. So Pythagorean theorem is that the hypotenuse squared is equal to each side squared added together. So c squared equals a squared plus b squared. And if we know that, then we can use that to solve problems. Just use our algebra, basic algebra, to solve a problem. Remember that c is always going to be your hypotenuse. That's the longest side of the right triangle. Okay, so if we look at example 5, in our particular triangle, we have this is 9 feet, this is 12 feet, and we're looking for what c is equal to. So c squared is going to be equal to 9 squared plus 12 squared. So that's going to be 81 plus 144, which is 225. And then that gives me c squared, but I would just want to know c. So in Pythagorean theorem, the last step you're always going to make is to take the square root of your c squared. So the square root of 225 equals 15. There we go. Okay. All right. So when is this kind of a practical, when do we get a practical application of using Pythagorean theorem? Well, if you think about computer screens and TV screens and the way they measure those, they always measure them as a right triangle. So if we have a rectangle, let's say that's our laptop computer screen, or our TV screen. It's mainly TVs. So that is a pitiful rectangle, but there we go. So the way they measure the screen size is we cut that rectangle in half and we measure the hypotenuse. Okay. Okay. So if we know the distance across is 28 inches, and the other side is 15.7 inches, then how do I find the hypotenuse? Okay, I'm just going to use the Pythagorean theorem. Okay, which comes out, in this case, it comes out to be approximately 32 inches. So when you say you bought a 32-inch TV, that's what you're talking about. The 32 inches is the diagonal of that screen. That's your screen size. It's measuring the diagonal of that. Okay. All right. And that is it for example 7 is just another case of using Pythagorean theorem. And that's it. Okay. So we'll be doing lots of practice problems for this section over the next few days. So if you have any questions, please make sure you bring them to class. Have a good day.